Welcome back. This is the third in the series of quadratics. In this session, I'd like to continue, I'm going to continue with the whole thing of the discriminant, all right? Because if you've got that table and you've written it down or you've downloaded it, essentially, once you've got that under the belt, these problems are very simple to solve, okay? And they carry a good chunk of marks. And here's the beauty. They are in every single test. They're in every single exam. And as sure as eggs, they're going to be in the finals too. So all we've got to do is make sure we know this bit. And there we go. We've got a good chunk of marks waiting for us at the end. The usual question is, given an equation, comment on the nature of the roots. For example, I chose this here. 2x squared minus x minus 4. 2x squared minus x minus 4. And they say, comment on the roots. Okay? That is, and they will even say, without solving the equation, comment on the roots. I mean, that is such a prod, isn't it, towards use the discriminant, because that's what they want you to do. All right? So let's have a look. What do? We, first of all, if we're going to comment on the roots, oh, my bad. Very often they say comment on the nature of the roots. Straightforward, that's delta b squared minus 4ac, and I say, right, here's my equation. And I take out a equal to 2, b equal to minus 1, c equal to minus 4, and put it in. B squared minus 1 squared. I put it in brackets. Hello, please do that. Minus 4 times a, 2 times c minus 4. So I get a delta here of minus 1 squared is 1. Minus minus is a plus. Where's my thingy? Minus 1 is a plus. And it's going to be 16 times 2, 32 is going to be equal to 33. So therefore, now I know what delta is, okay? Now I go back to my equation, my spreadsheet, and I say, right, it is real. The roots are going to be real, unequal, and irrational. Okay? Real, unequal, irrational. Because what do? We go back to the spreadsheet of the little thingy I gave you, right? The little flow chart. And you can see, always follow it down. It's real, then it's this way, then it's that way. So you follow it down, starting off real, perfect square, not unequal, blah, 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 equal to naught, etc. And just follow it down like that, okay? Right. Now, the next question is, what value of p makes the roots non-real? Here's another example here. They say to us, minus 2x squared plus 4x minus 3 equals minus p. All right? And they say, what value of p makes the roots non-real? These are discriminant questions, correct? So therefore we have to say, but hold on, what's the mistake? What's the bugbear there? The bugbear is p's on the wrong side. They say p, they'll tell you p is an element of natural numbers or integers or whatever. Okay? But in essence, they're looking for what value of p, what number must I make p? So I can make p 10, minus 5. What is it that makes the roots non-real? So I have to get it back to a standard quadratic, right? Why? Because I need delta. I need the discriminant. I need that. So to get it back, I've got to take p to the opposite side. It's on the wrong side. Remember, p is a number. So therefore, it's got to go with the other numbers. It's a constant. Minus 2x squared plus 4x minus 3 plus p equals 0. Right. Then what do? I take out the discriminant and I say delta is equal to b squared minus 4ac, but I must take out my a, my b, and my c. Well, let's take out a is equal to minus 2. Let me refresh your memory. It is the coefficient. B is that and C is that. But hold on. What about that? We'll get to that. Let's just put down first of all what B is. B is plus 4. C, hang on. C is going to be, C is minus 3. Yes. Minus 3 plus P, isn't it? So the constant C is minus 3 plus P, because we don't know what P is, but it is a number. It's going to change the value of the constant. So therefore, I say B squared is going to be 4 squared minus 4 times A is minus 2 times minus 3 plus P. And let's work that out. We work it out and we get 16. That's going to be minus 4 times, and let's multiply this out. That's going to be plus 6, okay, minus 2p, correct? This is going to be 16. Now I can multiply that out. Minus 3, okay. I end up with 8p plus 8p, okay, plus 8p and minus 24. And my final discriminant is going to be equal to 8p minus 8. Now, so I first work out delta. Then I say, okay, what must delta be? They tell me that in this case, they want the roots to be non-real. So that means, therefore, delta must be less than 0. Therefore, delta 8p minus 8 must be less than 0. 8p must be less than 8. Take it across. Remember, the sign doesn't change. It only changes if you multiply or divide by a negative. Okay? Lastly, I'm going to solve that. Right? Therefore, p must be less than 1. All right? You can go ahead and put it in, and you'll see that you will get, in fact, the square root of a negative number, which doesn't work. Okay? The next thing is I'm just going to carry on with this one, right? Because it's just a fun one. All right? What value of p will yield real equal? Real equal roots. So I go to the flowchart and we say real. Okay, go down the real side until you get real and equal. Therefore, what do we say? We say that it must be, delta must be equal to 0. I have worked out delta already. It's 8p minus 8 must be equal to 0. Therefore, 8p must be equal to 8. Correct? Therefore, p must be equal to 1. And if I put p equal to 1, I will get real equal roots. Okay, so once I've worked out delta, I then go to my little flow chart and say, what are they asking me to make delta equal to? Right? What will the value... Oh, okay. What value of p will yield unequal rational roots? Unequal rational roots. All right? So unequal, okay, well, unequal rational, I must actually add real in there. All right? Real, unequal, rational. It tells me delta must be a perfect square. And if delta is a perfect square, and they tell me in this case p not equal to 1, therefore delta must be equal to, the next perfect square is 4, isn't it? So what do? I then say, right, I solve for it, b squared minus 4ac, 8p minus 8 equals 4. Therefore, 8p must be equal to 12, all right? Therefore, it's going to be equal to, p is going to be equal to 12 over 8, which is going to be equal to 3 over 2. All right? Okay, let's put in p as 3 over 2 minus 2x squared. I'm just back substituting, plus 4x minus 3 plus 3 over 2. Okay, let's have a look. What does that mean? It's minus 2x squared plus 4x minus 1.5. Okay, and now if we go and we look at that, right, if you put it in, you get x1 equal to 3 over 2 and x2 equal to a half. Okay, so that's going to give it to you, and your delta comes out to be a perfect square of 4. Right? The last example in this one, I think it is, I'm not sure. Just have a look. Yes. The last example in this one over here is going to be this. It's going to be, let me just put it down here. The example, they say x squared plus mx minus m minus 2x plus 1 is equal to 0. Comment on the nature of the roots, okay? Or prove something associated with the roots of a quadratic. Doesn't matter how the wording is. Look at delta, okay? So first of all, we need to rearrange this because this is a variable. This is a constant. That's a variable. That's a constant. So we need to do a little bit of pre-work like that. Okay, minus m plus 1. Can you see? Let me just see. We've got the variables grouped and we've got the constants grouped now. All right. Now I can take out my a. A is equal to 1. Okay. Let's just reinforce this. Oh, but hold on. I can't. I've still got a bit of work to do. I've got to factorize this a bit more. So let's carry on. Take out the x here times m minus 2, correct? Okay. Minus m minus 1, or you could have just left it as minus m plus 1. It makes no difference to do so. All right. So now I say, okay, now a is 1. B is equal to m minus 2. And c is equal to minus m minus 1. Can you see? That's why it makes no difference, because that is in effect minus m plus 1. Or 1 minus m. Same thing, correct? Okay. Same thing as 1 minus m. I just want to get rid of that before we end up multiplying it by something. That is the same as 1 minus m. No difference. Right, now I can find the discriminant. Delta is equal to b squared minus 4ac. B squared is m minus 2 squared. Okay, minus 4 times a is 1 times minus m plus 1. You see that? That's the critical part here. Okay. Now, just let me rewrite that properly. Okay. It's going to be minus times m minus 1. I'm taking it like that, okay? Just for whatever. That's going to be m minus 2 all squared, okay? Let's simplify. This is going to be m squared minus 4m plus 2. And over here, this is going to come out to be minus times that is plus 4m minus 4. Let's have a look what happens. Oh, hold on. That's a 4. So let's just have a look what happens. The 4 cancels out. The 4m cancels out, doesn't it? So we are left with delta is equal to m squared, right? Which basically means it's a perfect square, right? So we can say, therefore, delta is a perfect square. Therefore, the roots will always be, let's go from the top down, shall we? Let's go from the top down. Real, okay, unequal, and rational. Okay, real, unequal, and rational. Okay, that's what we're going to get with those roots of the equation. Okay, so in all cases with these things here, essentially, what do? We go and we work out delta. Okay, that's the key to this. The next section of work is quadratic inequalities. Okay, now before we start that, all right, what do you still remember? Let's just refresh quickly the things of inequalities and number lines, right? If we had x greater than 5, put on a number line, we've got our 0.5. We look underneath the equality sign. There's no equal to. Therefore, this is a, this is a hollow dot. So what do we do first? We look and see where's our number. Oh, okay, it's bigger than 5, but it cannot be 5. And bigger means it's going that way. Then obviously they will tell you whether it's integers, natural numbers, n0, or real numbers, okay? In this section, we're going to be pretty much dealing with real numbers, okay? So in essence, they're not going to necessarily always stipulate in the question that x must be an element of real numbers, integers, or whatever. Generally, I think it's taken as read at this stage as being, we're going to be looking at it as real numbers, right? So we've now got a situation where we've got a quadratic equation. X squared plus x minus 6. And they want to know, where is that greater than 0? Right? First of all, you always put your 0 there, okay? Take everything to the left side, get a 0, okay? There's a reason for that, okay? It's because we want to draw the graph in actual fact. Because the easiest way to do these is a quick sketch of a graph, okay? Because you know all the salient features. Because you're going to have to find the roots of it anyway, all right? Why? Well, because we're going to have a look at this thing like this. Let us put, for the time being, let us say it's a graph, okay? What we first of all do is let's find the roots. So step 1, let's find the roots of this. So it's x squared plus x minus 6. Put it equal to 0 because we want the roots. So let's say, there we're going to factorize it, okay? We've chosen a nice easy one, and it comes down to x plus 3 and x minus 2 equal to 0. Right, now what do I know? Okay, let's have a look at my graph, all right? Okay, I know a is greater than 0. A is in fact equal to 1. There it is, right? Coefficient of x squared. So what do I do now? That means, therefore, my shape is a happy face shape, okay? Like that. Quite a cool way of looking at it. It's a happy face shape. Okay, what next? Next, I know it cuts at minus 6 as well. We are not at this stage interested that much in the minus 6 down here, nor the turning point. We're only interested in the number line of the x-axis at the moment. So, I know it's that way. It does that, and it cuts at minus 2, minus 1, minus 2, and 1, 2, and 3. So there's my roots of my quadratic, and it's a plus face, which means it does that. And pretty much we don't care what it does down there. I'm just drawing it in for completeness sake, because I personally think it's great practice to draw the graphs, because it gets you into rapid drawing of graphs. Oops, that was my bad, wasn't it? And he did it again. Because, okay. So there we go. That's what our graph looks like. Now, the next step, okay, let's just put it in here, is draw in the sign change lines. What are the sign change lines? It's where the y value changes sign. So you go there. Essentially, it's the roots, all right? Because this is the place where the y over here is plus, 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 minus, minus, minus y down there, all right? Because what are they actually asking? And this is where we need to clear up this confusion right away. They are saying, where is that quadratic? Where is f of x greater than 0? F of x is y, so where is y bigger than 0? Let's expand it. The actual question is, what values of x will give me a positive y? That's what I'm asking. Let's just look at it again. F of x, okay, greater than 0. Hang on. Here's my f of x over there. Where's that greater than 0? Well, it's what x's must I put in to get a positive y? Okay. So over here, we start off like this. You go to your sign change. Your graph here is plus. Can you see it's in the plus y? Here it's in the minus y. And at the root, it changes back to a plus. So therefore, if I look at it, any value of x that I put in over here is going to give me a negative y. So in order to make sure my y is positive, I have got to put in numbers that side and numbers that side. Okay? So what do? I basically go to it and I say, okay, let me put in my intervals. The intervals are, in this case, the graph I've got minus 3, okay, there it is, and we've got plus 2. Okay, to this side over here, to this side, it's going to be positive. So I'm looking, therefore, that side, and I'm looking at it there. Now I go back and I look and I say, is it a hollow or a solid dot? It's a hollow dot both sides because it's greater than or equal to, right? So therefore, my final answer is x must be greater than 2 or x must be less than minus 3. All right? You can put that in 1 by saying minus 3 greater than x greater than 2. Because it cannot be equal to those. Okay? That's where we've got that the inequality there. So what do we look at? We look, first of all, we look at the signs. Okay? We've got to look at the signs, the change of sign. So step 1 is we factorize and find roots. Okay? Then we look on our x-axis and put in what it's not allowed to be. So I'm going to go and I'm going to say, okay, right, when I'm drawing this, I say, sorry, I'm not allowed to have that number or that number. I can tell you straight away. I can't have them because it must be greater than, cannot be equal to. So therefore my roots as x values are not allowed to be that value to make this thing true. Then I look and I find my sign change. These green lines here are my sign change there and my sign change over there as well. All right. You're going to see we're going to get into some of them. We've got 3 or 4 sign changes as we move through. Okay. Now, I would really recommend that you take this one, all right, and take one out of your books and just follow the recipe for it. Put it down, find the roots, plot the sign change, and plot the little graph. No, to be honest, I have to be. This is not really necessary down here. We don't really need that, okay? It's just to get you into thinking that you can plot these things quite quickly. And it's kind of going to show you where the axis of symmetry should be. It's to get a feeling for it more than actually, because we are only interested in what's happening on the number line. Then you check, is it a greater than or equal to, less than or equal to? If there's an equal to sign at the roots, you put a solid dot straight away. If there's not equal to, you put a hollow dot straight away. Okay? Then you look and find on your sign change, what are we looking for? We're looking for y to be positive. Remember the question, what is the value of x that will give us a y that is either plus or minus? Okay? It's not that difficult. It looks it when it first starts, but please take 1 or 2 and give them a practice, follow the recipe. I'm going to come back and I'm going to do a -1 and a few more of these. Okay, we're going to kind of focus on these for a little while and intersecting graphs and things like that. So we're building up towards graphs. Cheers. I hope that was informative and I hope you followed it. Remember how to do these. Go with me, do the drawings, stop, go back, write the recipe down as we go. Cheers. Have a good one. Bye.